We are starting the day with large language models, how to redefine user experience with them. That we will hear from Igor Ilic, who is Principal Applied Scientist with Office team at Microsoft. Prior to his current role, he led data science in Microsoft Azure Data, implementing AI in cloud database systems. Igor, please welcome to the stage.
Thank you. Okay, that was not the best photo of me ever. Anyway, thanks a lot. When I started making this presentation, actually I started with, I wanted to talk about next generation interactions. But then I found out that actually it's supposed to be 45 minutes long, so like you cannot talk for 45 minutes without having some technical topics as well, diving deeper. So I wanted to avoid that because this is a keynote. And so basically I'll have two topics. One is going to be a bit about the Copilot and, okay, what we are building in Microsoft, how we are building it, how does it look like to actually work on such a product. And then like I'm going to talk about the main topic of today. So basically it's about how large language models are going to impact the products that we are building for tomorrow, right? So, okay, I'm going to talk a bit about, okay, what we have today, just to sort of structure the conversation a bit, and then how products are probably going to look tomorrow, right? Okay, first about the Copilot, right? So I'm gonna take a wild guess and guess that most of you have heard about Microsoft Copilot. It's a sort of a tool or a suite of products which is actually now engraved within every Microsoft app, right? So Office, so basically PowerPoint, Word, Excel, Teams, Outlook, wherever you look at, there will be a Copilot. Maybe you didn't get it yet, but you will at one point. And so basically, what is the difference between the Copilot and ChatGPT, right? So ChatGPT right now, when you go into it, it covers general knowledge, right? So it's been trained on the internet, of course, and it can answer all sorts of questions which are related to general knowledge. But there is a lot of proprietary knowledge that you have within your documents and emails and everything, which it doesn't cover, right? So basically, Copilot is actually grounding the knowledge within your documents, within your proprietary knowledge, and it can sort of help you with various stuff. So instead of me talking about it, like I took this nice video from our sales team or marketing team or someone who knows how to make nice videos, and I'm going to just play it. And I'm going to talk over it because it's just some music, right? So actually, it can do a lot of stuff, right? So basically, because it's grounded on your documents, it can sort of prepare you for the meeting. So it has all the meetings that you have, all your emails, all your documents, and it will help you prepare for the meetings, create Word documents, right? I mean, some things it can do right now, some things it will be able to do. This is just like a sales pitch, right? But still, this is in Word, and for instance, it already exists. It can help you create a presentation from scratch based on the documents that you already have. And then it can help you analyze data in Excel. So basically, it can also, I think after this, is the Teams meeting, where it can help you actually create automatically meeting notes. It can, when you get in the middle of the meeting, you can actually see, okay, what's going on, what happened so far, because you missed half of the meeting. It actually happens to me a lot. All sorts of stuff which are grounded on the data we have about you, and that's a lot of data, right? But yeah, so basically everything that you do in Office is preserved. Like we can't see the data, but actually it's already stored, and it's used in the Copilot for grounding of these products. Now, as I said, Copilot is going to be in every single product, right? So it will help you create presentations, analyze data in Excel. But what we're doing in Serbia here is actually we're making Copilot in Word, right? So imagine your own ghostwriter, basically. You want to sort of create any document or rewrite it or whatever you want to do. Basically, you have your own personal ghostwriter, which helps you do any of those stuff. So it can, right now, summarize your document, rewrite a paragraph, create custom graphics, but also it can create a document from scratch. Now, instead of me talking about it, I again have a sales video. And this time, actually, Sangai talks over it.
You need to create a customer proposal and don't have time for writer's block. Copilot can draft a proposal based on your customer notes in OneNote, as well as another internal document. Copilot scans the target files and gets to work, quickly generating a first draft with all the key details from the files you provided. Now let's say you want this to look like one of your previous proposals. Copilot can give you a draft in the format you typically use by specifying a reference file, and it can also insert relevant images from another file. To add the final polish, Copilot can generate a short summary at the top of your document and also suggests ways to strengthen your proposal, with options such as adding an FAQ, which it will generate for you as a starting point for you to refine and add to. Copilot has taken a tedious task, simplified it, and freed you to focus on the details that matter most.
So basically, we have shortened the period of creating a document to just a couple of clicks in this perfect scenario, of course. But in real life, actually, so because we've been using it for some time in our, within Microsoft, it actually really makes like these tedious tasks faster, right? So how does Copilot work? This is just a very high level, quite inaccurate picture of how it looks like, but basically it's a good representation. So when a user actually invokes Copilot, they are sending some prompt to the Copilot, right? And then Copilot takes this prompt and then sends it to Graph. So basically Graph is this storage system which contains all of the emails, all of the documents, meetings, everything that you have, right? And including the organizational data, right? The hierarchy, the people, and everything. So it's grounding itself in that data, pulls out the relevant context, and then together with the user prompt, mixes it up and sends it to the large language model. Microsoft, as a backend for Copilot, uses only OpenAI models right now. And then once it gets the response, it goes back to the Copilot, which calls the Graph again to see, basically to validate the data, to do some sort of post-processing, and then finally goes back to the app to either issue a command or give a response to the user, right? So this is an oversimplified sort of description of how it looks like. Actually, this might look like a RAG system. It's not a RAG system. It's like an agent which does some reasoning over the data, so it's much more complex than this, but I think this is a good representation of how it looks like. So I just wanted to cover just a bit on how it looks like actually to work on the Copilot and everything that, at least our team covers when we are building this in Word. So, okay, first of all, there is prompt engineering. These prompts in the back end, actually, whatever you send to Copilot, okay, is a user prompt, but then it's sort of embedded within a huge, super complex prompts, which are the Copilot, right? And these complex prompts, they need to be quite general. So basically, they need to cover hallucination, responsible AI, and all sorts of stuff, just like sort of safety guards, but also provide consistent responses. Because for some reason, this is actually what users want, a consistent response and similar responses when they have similar prompts. So this means that because of these prompts are really complex, we need to evaluate every single small change in the prompt. So we need to build like these automatic evaluation systems, which are based on GPT-4, and then also manual evaluation, where like we have a bunch of labelers who are evaluating whether we mess something up, right? There is also AI engineering part. I mean, I'm calling it that way. I don't know if there is a terminology yet for that. But basically, we, as I said, we are building agents with iterative planning for which are sort of doing the reasoning loops over the graph data. And then also, we are fine-tuning smaller models when we can, right? There aren't still a lot of cases when we can actually use smaller models, but still, we did use some, for instance, for rewriting sentences and stuff. And then also, like, actually, the majority of work is around safety. So, like, you wouldn't believe the lengths that actually we need to go through, for instance, for responsible AI. We had, like, access to unconstrained models, like, just fresh out of the oven from OpenAI, and actually, I mean, they really, really gave some horrible, horrible things. Like, it can guide you into, like, really serious crimes, like, if you wanted to. So basically, it's something that, I mean, I wasn't a huge fan of responsible AI at the beginning because I saw it as bureaucracy, but after actually I got access to this model, I understood why it's important, and I really mean it. So, so there is a lot of effort going around responsible AI. Of course, there's privacy, compliance, legal, everything which a large corporation needs to, for instance, and legal is crazy actually, and privacy as well. Like last week, I had a meeting on training or on some new Vietnamese law, which now we have to obey in our products. I don't know. So basically, you need to obey laws of every single country in the world. And then there are other safety efforts like prompt injection. So basically, right now, prompt injection is a lot of people make it analogous to like SQL injection. Basically, so it's a new way of hacking where actually, if large language model is connected to some external data source like Microsoft Graph, you can actually prompt inject into your documents to make large language model extract the data to which you don't have access to from Microsoft Graph. So basically, this is something that we are trying to protect against, and this is a huge effort in Microsoft to be safe and to just make safe products, right, in this regard. Shameless plug, we are hiring across all roles, so if you know anyone, just go ahead and within our team. Okay, so on to the main topic of the talk. I'm going to talk a bit about first types of user experience. We are changing gears completely here, right? So in order to be able to understand, okay, we want to understand how large language models are going to impact the products that we are building today. So in order to understand how they are going to change, we first need to structure how they look like right now. So basically, I'm going to split user type interfaces right now into three wide buckets. Basically, I mean, there are many, many ways to sort of define the types of user interfaces, right? But this is the way that makes most sense to me, at least this is what I found. So basically, you have simple task-based applications, which are your mobile apps, like search and select interfaces, which are like e-commerce, like Amazon and stuff, and complex system operation interfaces, which are really complex professional software, right? So let's briefly go into each of them. So search and select interfaces. As I mentioned, these are like mostly e-commerce websites, but also stuff like, you know, API documentation or anything which is search focused, right? So these are usually websites or softwares with a large stock that you need to search over. And here, there are two things which are most important. They need to be intuitive, and search results need to be very relevant. So basically, here today, good filtering is like probably one of the most important things that you can have within these UIs. So I'm going to cover later how they will be potentially disrupted using large language models. Also, we have simple task-based application. These are your TikToks, Instagrams, Facebooks, stuff like that. So basically, people usually, so these are consumer products, right? So people, when they go home, they want to watch, you know, they don't want to have any cognitive load outside of work. They want to watch romantic comedies, sitcoms, and when they're using some applications, they want to do it in an intuitive, repeatable way without learning anything new, right? So basically, that's why you have like a so this is, for instance, TikTok UI, I think. So, and basically, you have like just a couple of buttons here. You can like, you can message, you can repost. And then there is the editing of the video, which is a bit more complex, but I wouldn't say it's rocket science as well, right? So basically, these UIs are made for simplicity and repeatability, and that's it, right? And then finally, we have complex system operation interfaces. So yeah, these are, you know, your professional software, right? ERP systems like SAP, Salesforce Dynamics, or Excel, Photoshop, I don't know, and others. And then basically, so expertise within these UIs is like, they are so complex that even the expertise itself is in market demand, right? So basically, you can earn a lot of money just by being an expert in these UIs, right? So why they are so complex is because for work, you need a lot of flexibility. You need a lot of customizability. And in order to have that, you need to have a lot of functionalities. And this actually implies very complex UIs, right? Okay, so now that we covered this, let's go into how I think, and maybe some others think as well, that each of these UIs is going to be disrupted, right? So this is a rough sort of split into how they can be disrupted. There will be, of course, some overlaps. There will be, of course, some, so this is not a rule of thumb, but basically, I think it's a good overview of how they can be disrupted, right? So we'll talk about chat, voice, adaptive UIs, and vision, okay? So, okay, let's start with chat. Chat is not really a new UI, right? So basically, chat is something that exists for a long time, but basically, right now, chat is either, okay, usually it's some live support on some website, right? Or if it's automated, it's usually some rule-based whatever, basically just some string matching algorithm. Right now, like, I think this is the most obvious example on how large language models are going to impact UIs. Actually, right now, using these RAG systems, you can actually search through the whole website or the whole documentation in natural language, right? So basically, imagine like, okay, it applies to Amazon or some furniture store on this stock image here, or actually it applies to any sort of API documentation, right? So you can just state what your intent is, and then based on that, get the relevant search results. You can, for instance, furniture store is a good example, because there you can say, okay, I have this, I don't know, brown couch, and I'm looking for some chair which will go well with it, right? And that's enough for you to get back the relevant results. You don't have to filter, you don't have to go through like dozens of chairs and everything. And basically, this applies to everything, even in the complex situations like API documentation. Like, you can just state what it is that you're trying to build, and then get back the results on not only the relevant parts of the API documentation for your case, but actually maybe even the code itself, right? Okay, so basically, this is below. I have the explanation of RAG systems and how they work, and which will and are the back end of these chat experiences right now. Again, very high level representation. For non-technical folks, I'm just gonna go quickly into it. So basically, okay, the laser works, but not on the screen. Never mind. So user asks a question. It goes into this smart retriever, which is just looking for relevant data within the documentation it has encoded already. So this smart knowledge base is actually, you can imagine it like the whole Amazon, right? Or the whole website, including some backend documentation that the user doesn't have access to. It retrieves the relevant documentation for the user prompt and then stuffs it together with the user prompt into the LLM, which gives you back the answer. This is pretty much the standard RAG. Now, like standard RAG, it works, sort of. But in order to really make it work, you need many advanced techniques. I'm not going to cover that right now, but if anyone is interested, we can talk about it later. Okay. The second is voice. Now, people have been typing since the invention of, well, not since the invention of computers in 45, but since like the invention of keyboard, right? And the reason why people type is because that was the only way and the most convenient way at the time to pass the information to the machine, right? And we got used to it, right? But it's not the natural way of passing documentation, and it's information, sorry. And actually, it's not a healthy way as well, right? So basically, a lot of the health problems that people are seeing right now are relating to, typing. And I'm not saying typing is going away. Typing is always going to stay. But basically, now we have actually models which help us pass the information in other ways, right? So basically, we have Whisper by OpenAI. There are also some open source models which are good. But Whisper is by far the most popular right now, which enable you to transcribe anything in real time. So basically, you can dictate, but you can also pass the commands to your mobile or your computer in real time right now. So the question is, okay, are people actually going to talk to a machine like that? Because we're not used to it, right? So you won't talk to the machine, okay, open TikTok or whatever, right? So we don't know, but the best proxy we have is voice messaging, right? So how much people are using voice messages right now? So I'm, for instance, not using it at all, right? I don't think I ever sent a voice message in my life, but apparently young folks use it much more than the older folks. So basically, this is a UK study from May this year, where you can see by the age group how often people send voice messages. And like there is a clear correlation here, and that teenagers and young folks are much more often sending voice messages. So basically, younger generations might send, are sort of used to talking to at least mobile in such a way. There are, like, what surprised me, there are 7 billion voice messages on WhatsApp every day. So basically, yeah, I don't know, but this is the best proxy we've got, that actually it's realistic to expect that people are going to be comfortable with commanding their mobile or their computer with voice. So I think, like, you won't use like voice for your Excel, to command Excel or anything like that, but you are going to hopefully, or maybe, use it for these simple task-based applications, especially for mobile apps, right? So basically, this will help, I don't know, TikTok or Instagram expand their capabilities, because right now you have free functionalities in TikTok, but hopefully, like with voice, you will be able to expand that without actually making the UI more complex, because for anything other than those free functionalities, you would just say to the mobile what you want, right? Okay, adaptive UIs. Now, this is the sort of most complex thing which I'm going to talk about today, but it's not like I tried to make it really, really simple. So hopefully. This is for this professional software, complex system operation software. So basically, you want actually to lower the expertise, the amount of expertise needed for using this software. This is the closest we can get to job automation today using large language models, in my opinion. So how do you do that? Well, using agents, right? So I don't know how many of you know what agents are, but they are the systems which are doing the reasoning over some tasks. Now, like, instead of just explaining this sort of high-level representation of agents, I'm going to go through an example on how it would do if we rebuilt some like light Photoshop using an agent, right? Okay. So let's imagine you have this light Photoshop which is enabled by a large language model. You upload this image of a puppy jumping or running or something, and then you just give it a natural language sort of command, which is remove the dog from the photo. This is your original target objective, right? So just removing the dog from the photo, and then you will see that the agent is coming back to this original request from the user. So what it does first, this prompt, it goes into the large language model, which is specialized. I mean, specialized in a way, it's either fine-tuned or prompt engineered in a way to break down the tasks needed to achieve this goal. So here, actually, it is aware. So imagine that the large language model is connected to all Photoshop's functionalities. It knows what each of the functionalities does. And basically, based on that, it takes the user prompt, it has all the functionalities, and it is able to break down this task in, so basically in unit tasks, which what Photoshop can perform. So basically here, it would, in order to remove the dog from the photo, it would have to first run object detection to actually search for the dog, and then run semantic segmentation to actually map the exact shape of the dog, enhance this mask a bit to avoid mistakes, and then also run in-painting mechanism to remove the dog and just sort of simulate the background which would have been behind the dog. And I'm going to talk about how adaptive UI goes into place. So basically here, let's say, okay, this large language model says, okay, first I need to run object detection. So it runs it, and basically it selects a dog, right? And then basically, but it can make a mistake, right? Either the large language model or the object detection. So what you get is basically a single functionality which enables you to either move this bounding box or resize it or do whatever you want with the bounding box. So basically a single functionality without all the complexities of like the huge software that is Photoshop. Then when you're satisfied with that, you click apply. And then it runs the semantic segmentation model, which then within that bounding box tries to, on a pixel level, select the dog, right? There are really good models right now which are doing that, by the way. And basically, then it gives you basically this brush, which enables you, if it made some mistake, to sort of delete the part of the mask or just enhance it or whatever you want. So basically, again, you have a single functionality, a single task at that point in time. After you're happy, you click apply, and now it goes into this automatic job. So basically, it increases the mask by 5%, like you don't need a human input for that. And then it runs the in-painting mechanism. So basically, just painting what it thinks would have been behind the dog. So like, I'm hoping a lot of you are familiar with Stable Diffusion. models which are able to perform this with a very good quality. So after it's done this, like it goes back to the LLM, and it has like the initial user prompt and this image, and it says, okay, this is the user prompt, this is the image I have right now after the first turn. Did I fulfill user's intent? And in this case, it did. But imagine, for instance, that we had like, I don't know, that the request was leave 2 dogs on the image. So the first turn would have to be, okay, just count the dogs which are on the image. So it would count, let's say it would have been 3 dogs. It would go back into this reasoning loop and say, okay, you have 3 dogs on the image, and now the second task would be, okay, remove 1 dog from the image, and then it will go through all of this, right? So, so it can go in loops until it actually fulfills the user intent, and give the final answer to the user. Okay, so this sort of adaptive UI can actually, in theory, be applied to any complex software, you know. So for instance, I don't know, ERP software, like any sort of financial statement that you need to build, it can be simplified using just natural language. Imagine a large language model knowing all the functionalities of SAP, knowing which actions it needs to perform in order to do some sort of financial statement, like it can do that. And it can even sort of fit the UI, that's a bit distant in the future right now, but fit UI for specific uses and for specific users as well. So, so that it continues to lower the amount of expertise needed to use any of these complex softwares. So yeah, I mean, at one point, like all of this can be done automatically, but I don't think we're at that point yet. I think we need human in the loop to check all the mid-steps within, like as you saw for Photoshop, you need to verify and validate every step on the way. And vision, finally. So this is a tool, I mean, it's an open source project called TLDraw. I really like this because it depicts nicely on what's coming. So here, a guy, I guess, because of the hair. So he's sort of making a counter, like using just sort of, he's doodling this whatever counter, and he's writing it, like, and he has a terrible handwriting, obviously, about what he wants to build. So he says counter, click to increase, decrease. He selects it, and he clicks make it real. So, I mean, it's no secret what will happen. It will work. I mean, it's so basically, yeah, it works. And like even crazier example for me, at least, was this one, where someone actually, so they drew how the chat should look like, and they just pasted a screenshot of the OpenAI documentation, which should be in the backend for the chat. And I mean, it works. It's in Spanish, but it works. So for me, actually, this was completely crazy. This is a really new stuff, and I think this was released like a couple of weeks ago or something like that. I don't know. But this is crazy. A guy or a girl, right, drew like a chat and pasted a screenshot of API documentation, just said, okay, create me a chatbot based on this API, and it works, right? So, okay, this is all based on this multimodal models, right? So GPT-4 is the most famous for that. It's released by OpenAI and now is part of ChatGPT. But also there are other very good open source models. There is Lava, there is Baklava as well, which is interesting that it's very good. And I personally think that this these models are going to change the way people interact with software. So basically, imagine, like for instance, this screenshot example. Like, if some product supports this, why would anyone type in one product when they can just use the other product by just pasting screenshots all over it and then finishing the job much, much faster without typing, which I said people don't like to do that, right? Or, for instance, I can just, if I use Word as an example, because I work in Word, right? So, like, why would I retype everything in component template when I could just paste like an image or a screenshot of some document that said, okay, here's the text, here is how it should look like, just make it work, right? So I think like visual input is going to become much, much more important, well, in very near future, actually. So it will take time for companies to actually build these products and based on these inputs, but I think this is going to have like a profound, well, it will create a profound change in how we interact with software. And especially when AR, VR comes, like this is Apple's Vision Pro, but like also Facebook or Meta has this like Ray-Ban and everything. So how that will work together with these models, I don't know, but it will be interesting to see. Okay, this is all I have. Thank you.
Surely there will be a question or two because I have more than a dozen. So anybody wants to ask anything? Well, I can start. I mean, how soon is this going to be a part of the Office suite?
Well, like for voice.
Why is it not yet in? Because I'm a subscriber to 365.
Okay. So basically, you need to subscribe to Copilot first, which is like.
So it's another subscription.
Yeah. So it will be quite expensive, to be honest. And yeah. So right now, what will be part of like Copilot is the chat and like the voice. But the other stuff, I mean, well, I hope it will come in the year or so.
So Copilot is somehow going to merge with my words in.
Yes.
It's simply an addition that we're going to use.
Yes,
and
exactly.
when did you say it is going to be?
It's already. So I think we actually shipped it for consumers like a month ago. But we shipped it to consumers a month ago. But so you can already use it. But like all of these capabilities, I think in a year they will be really rolled out.
Okay, enough with propaganda now about about serious questions, if there are any. No, not yet.
I think. Yeah.
Oh, sorry, I don't see. Yeah, please.
How about now? Yeah. So I just want to know, do you build and train your own models, or do you just prompt OpenAI's models?
So we just prompt OpenAI's models, and we sort of fine-tune smaller models as well, but we don't train anything from scratch. Of course, there are some, but there are also some smaller classifiers that we're looking into training, but these are just smaller parts of pipeline. And for the main models, we are prompting the OpenAI models. Yeah.
Okay, thank you.
No worries.
I think there's a hand raised behind there.
Hello. Oh, great. Igor, great presentation. Really loved it. Thank you for spending your time explaining all this fancy stuff to us. I just have one question. I really like Microsoft is doing like responsible AI, and I really adore these lovely examples of how this will impact the user experience in general. I was just wondering, have you guys ever considered being responsible for developing an AI? Being responsible for lowering general human intelligence, because all these products, they really, skip some important steps in human development. For example, you mentioned that guy has a terrible handwriting. So I mean, using human hands can develop really important stuff in human brain, and all this stuff is great if you have already developed, human in developed stage, so to speak. So that's why I was wondering if you are being responsible doing an AI, have you even considered, you know, having some age restrictions for your products, or even, yeah, I don't know, questioning your audience or people who are going to buy your products? I mean, you understand the point.
Yeah. No, it's a good question. So, so actually, for age restriction, there is a UK law. Unfortunately, I know about all of those laws, which is called age-appropriate design or something like that. So basically, within which we have to make sure, in any way, that the user which is using some of these products is over 18 years old. I think it's 18 or 16, I forgot now. But so basically, there is this, so I mean, of course, it's abidance by law. It's not something that Microsoft made up, you know, because of I don't know what. But basically, this UK law actually impacts the whole world, because we're not going to build software just for UK. We're just going to, so also GDPR, it's EU law, but then we're respecting it throughout the world, right? Because we don't want to have different versions of software. So it's this way as well. So regarding your question to age-appropriate design and everything, actually it's already in place. And so which parts of this software kids are going to be able to use, which they're not, I don't know so far. They wouldn't be able to use this type of software. Whether that will change, I don't know. And the second thing regarding lowering the whole human intelligence, I mean, yeah, I don't know. I'm just looking right now like this is a challenge for me to sort of develop, and yeah, I'm not looking into long-term consequences. And I guess like maybe we're going in the wrong direction, but. Like, I don't know. Even if Microsoft pulls out of this AI race, I don't think it would change anything.
Well, if I can counter that question, are we going to communicate with the software more by handwriting? Because presently, we are mostly communicating through the keyboard. So this can change. I barely use pen when I'm working on a computer.
That's a great question, actually. I haven't thought about it. For me personally, yeah, I don't know. Like, I guess like it depends on what you're most comfortable with, right? So basically, I think younger generations, they're not going to write anyway.
But if I can draw a house, and if I say I need this house to be made in 3D, so it can do it for me instead of explaining and doing all the stuff. So, and the other question is, I'm sorry, is there anybody waiting for? Yeah, just briefly, the other question is, are you going to put the transcription of the voice messages? Because I don't like people to hear the voice messages I'm getting from my daughter.
Okay.
I'd like to read them rather. I mean, I like her voice, but I'd like to read them when I'm in company of other people.
That's a great question. So basically, so first of all, like WhatsApp, for instance, like I did some back of the napkin calculations. If you want WhatsApp to transcribe every single voice message, it will cost them annually nearly $10 billion. So, well, it's not a small amount of money just for transcription of voice message. That's why they're not doing that. And I don't think they'll do it until it becomes at least 2 orders of magnitude less costly, right? So, and for these softwares and interfaces, for instance, ChatGPT already has that, the application. When you say something to it, it first writes it, transcribes it, and asks, okay, confirm this. So, I mean, you can read it. So in some softwares, you can already read it, yeah.
Okay, quickly, 2 questions I think we can still cover. 1 second. Yeah. Sorry.
Thank you for presentation. I have a question about adaptive Photoshop you showed. So there was like instruction from user, and then was reasoning to break down to tasks. And are these tasks then classified to some predefined tasks that can solved by models, or it's like more flexible, or it generates codes? So like it's only just fixed set, like outpainting, inpainting, segmentation, and so on, or it's more general?
No, it's not general in the way that you're describing it. So basically, you need to define the description of every functionality that you want to be supported using this, this system, right? So basically, it doesn't know, and it shouldn't know about any tools which are outside of the system, because then it becomes much less stable. It doesn't know how to generate the code exactly, because in the backend, actually, this system is generating the code which is going to be executed, right? So you don't want it to just go like wild. Anyway, so basically, you want a stable system, and for that reason, you are defining the tools which you want for the agent to be able to use.
Okay, we have to finish now because we're already 7 minutes in the next presentation. Igor, thank you. This is a certificate of being a presenter at DSC. Thanks to Igor for his presentation.
Thank you.